Section 4.4, factoring polynomials, beginning on page 180. Up to this point, really are, for the most part, we've been factoring quadratics, where they're only x squared. So we only been quadratic, so basically polynomials with 3 terms. Okay. Now we're basically just going to apply what we know about factoring quadratics, learn a few new tricks, and apply them to factoring higher degree polynomials, things like x to the third, x to the fifth, so forth and so on. First of all, we need to talk about what it's meant when we say factor completely. When we say something's factored completely, it's written as a product. Again, product just means to multiply. Product is a multiplication. A product of unfactorable, okay, a product of unfactorable polynomials with integer coefficients. Meaning we don't want any fractions. That's what we mean by integer coefficients. Integers, like no fractions or decimals in that. Okay, so really a lot of it, we're just going to apply our previous methods to factoring. Our factoring out common factors, guessing and checking, so forth and so on. The number one, very first step when factoring is to factor out common factors. So first, factor out common factors. Factor out the stuff they have in common. Always be looking for those common factors and factor that stuff out first. Okay? For example, in this first example 1, part A, I'm going to look for anything these 3 terms have in common. Well, they all have an x in common. So I'm going to factor the x out front. So here I'm going to be left with, well, x times what gives me x to the third. So I'm left with an x squared if I take one of those x's away. If I take one of the x's away from there, I'll have minus 4x. If I take one of the x's away from there, I'll have minus 5. So now after factoring this x out of this cubic polynomial, I now am left with a quadratic polynomial, and we can just apply our old methods. For this one, I think we're going to guess and check x and x. Hey, want to multiply to get to negative 5. I want to add to get to negative 4. 5 and 1, negative 5 plus 1. Let's double check. X to the second plus x minus 5x gets me the negative 4 minus 5. Okay, so now I want to double check. Can I factor any further? So I've got x, x minus 5, x plus 1. Nope, I think that's it. There's nothing in common in any of these. So there it's factored completely. So always, first and foremost, factor out those common factors. Okay, for example 1, part B. Again, first and foremost, factor out the common factors. So let's see, I've got a 3y to the 5th minus 48y to the 3rd. I'm pretty sure 3 is a factor of 48, so I can factor out the 3. And then how many y's can I take out total? I think I can take out 3 of them, because that's the most they both have in common, so I can take out a 3y to the 3rd. So now I ask myself, 3y to the 3rd times what gets me 3y to the 5th? I've taken the 3 out, I've taken out 3y's, that's going to be y to the 2nd. 3y to the 3rd times what gets me negative 48y to the 3rd? Well, 3 times, I have to divide the 48 by 3, which is minus 16. And then I'm taking out those 3y's, so there I'm stuck with 3y to the 3rd, and then y squared minus 16. So I factored out a common factor. Now I need to look with what's left. With what's left here, can I factor that? So look at this thing right here. Is there anything I can factor out of that? Well, y squared is a squared, 16 is a square, and it's a minus. That's a difference of squares. So that'll factor with my difference of squares. So that would give me y plus 4, y minus 4 if I use the difference of squares. So we're going to have to remember our previous factoring rules. So there we're completely factored. 3y to the 3rd, y plus 4, y minus 4. Okay, next, C. Again, look for common factors. Look at my coefficients. 5, 30, 45. Well, a 5 comes out of all of them. And then z to the 4th, z to the 3rd, z to the 2nd, so I can take out 2 z's, the z to the 2nd. So then if I take out a 5z to the 2nd from this, I'm going to have a z to the 2nd left. When I take out a 30z to the third from that, and I take a 5z to the second out, I'd have plus 5 times 6 is 30, and then I'll have 1z left, plus, and then 5 times 9 is 45, and both my z's are gone. Okay, so then now let's see if we can factor the quadratic that's left behind. Multiplies to give me 9, adds to give me 6. 3 and 3 gives me 9, so it's going to be plus 3 plus 3. So I can write it as z plus 3 times z plus 3. But since I've got two of them, I can shorten it up and write it as z plus 3 squared, because that's what we call a perfect square trinomial. So there I'm completely factored. Okay, now I'd like you to pause the video and attempt the monitoring progress problems 1 through 3. They're very similar to example 1. All right, welcome back from doing your monitoring progress problems. Now let's talk about a different type of factoring. This one is new to us. This is the sum and difference of cubes. It's very similar to our difference of squares up here. So when I had a difference of squares, so when we had a squared minus b squared, hey, remember, this is the square of a, this is the square of b. So this will factor into a plus b, a minus b. And remember, we needed to be familiar with our squares. 1, 4, 9, 16, 25, ... Now we're going to extend that to talk about the sum and difference. The sum, remember that's addition, and the difference of cubes. Our cubes are numbers to the third power. Like 1 cubed, let's go ahead and let's list out our cubes up here. Let's see, 1 cubed is 1, 2 cubed is 8, 4 cubed is 64, 5 cubed is 125, so forth and so on. These we don't tend to memorize as much, so we constantly have to be looking for those cubes and seeing if they are cubes. Our calculator is a great tool for that because we can just cube a bunch of numbers and see if it matches. But for a sum and difference of cubes, again, let's write down. So a cubed is the cube of a, b cubed is the cube of b. Here's the rule for factoring a sum of two cubes. So what I do is, first things first, I write the things that I cubed, the a and the b, and I just add them. So it's going to be a plus b. Okay. And the next step, I take this first thing, my first cube here, and I square it. So we'll take a squared. And then I change my sign. Since this is a plus, I'm going to change this to a minus. And then I multiply these two times each other. So I multiply the a times the b. And then finally, I add the last term cubed. Now, if I was to multiply this out, if I was to distribute and multiply this out, I would get back to this thing here. Hence, this is a shortcut rule for factoring a sum of cubes. Hence a sum, because I'm adding two cubes. Okay. This also applies for the difference of cubes. The only difference is this would be a minus right here, and so that would make this a minus right there, and it makes this one a plus. It's really the only difference is it changes those signs. So really, to use sum and difference of cubes, what you need to be doing is looking for these cubes. Okay? So let's go ahead and let's do an example with using a sum and difference of cubes. So first of all, here example 2. First of all, I'm looking to see, are these cubes? Well, I can tell this one first is a cube of x. What's this the cube of? Is it a cube at all? Well, I did write it down here. 5 cubed is 125, so this is the cube of 5. So these are going to act like my a and my b up here. So now to factor these, again, this is a minus 1, so I'm going to be looking at the subtract 1. So to factor this is going to be equal to, so when I factor it, I take these two things and do the same sign as here, so I'm going to subtract them. X minus 5. And then I'm going to multiply that by the square of the first thing, so I take x and square it. And then I change my sign, because if it's plus, it's minus. If it's minus, it's plus. So since this is minus, this one's going to be plus. Then I multiply the 5 times the x, right? The a times the b, so the 5 times the x, so that's just 5x. The last sign is always plus, and then I square the last term. 5 squared is 25. So this is how a difference of cubes will factor. This quadratic is not factorable. You can try, it won't factor. Okay, so this is completely factored right here. Okay. All right, let's look at example 2. Sometimes starting out, you can't quite tell it's a difference of cubes, like in this case. But again, our number one step from up here is to always factor out any common factors. Well, 16, let's double check and see if 16 goes into 54. Let's take 54 and see if I divide it by 16. Not quite. Well, let's try some other numbers. What about 4? Because 4 goes into 16. Nope, so let's try something else. What about 2? 2 will work. So I can take out a 2. So I'm going to factor out a 2. And I can also factor out some s's. I've got 5 of them here, 2 of them there. So we'll take out 2 s's. So what am I left with? So 2 times 8 is 16, and I'm going to have s to the third, plus 2 times 27, and then I've already got my s to the second. Okay, so now I need to look, is this a sum of cubes? So I'm always looking to see, does it fit that rule? Well, 8 is a cube, it's a cube of 2. S is a cube, it's s cubed is a cube, it's a cube of s. But now we need to check the 27. You notice up here I didn't write down 3. So let's double check, what is 3 cubed? So in our calculator we go, 3 cubed is 27, because 3 times 3 times 3 is 27. So this is the cube of 3. So 2s cubed is that, and then 3 cubed is that. So these are both a sum of cubes. So that means I can factor them. This 2s is going to hang out front, so I'm just going to bring that 2s down. So this 2s to the second is just going to hang out front. Okay, and then now we look at our rule. So I'm going to take, first things first is I take each piece and I do the same sign as this. So since it's adding, I'm going to add these two things. So I'm going to add 2s plus 3. Okay. Now next step, parenthesis, I take the first thing and I square it. So I'm going to do 2s and square it. When I square both of these, I'm going to get 4s to the second. Okay, then I change my sign. Instead of plus, it's going to be minus. And I multiply these two things. So I'm going to take 2s times 3. 2s times 3 is 6s. And then plus, oh, that should be a squared. Oh no, type O. Type O, fix it, fix it. Should be squared. Last term squared, I wrote cubed. So I take my last term here and square it. So plus 9. Okay, so there's the difference of cubes. So really, you are going to need to know that little tidbit for the test, for the quiz. This little bit is important. Okay, this thing here is important, knowing how to factor a sum and difference of cubes. Okay, next page. Okay, now we're going to do some factoring by grouping. Okay, how factoring by grouping works is this is most useful when you have 4 or more terms. If you have 4 or more terms, factoring by grouping is always a good place to look. And how factoring by grouping works is we actually factor by grouping when we do organized factoring. You remember organized factoring of quadratics? That involves some factoring by grouping. Okay. So to factor by grouping, what we do is we actually take the addition and we group the first two normally and the last two. You might have to do some rearranging sometimes depending on how you group. What that means is I'm going to add these first two first and still have an add in between, and then these next two. So again, this is still adding. Just because there's parentheses doesn't mean we're multiplying. Okay, I'm just changing the way I add. I'm going to add the first two, and then add the last two, and then do the add in the middle. Because what that does is in these first two, they both have an r. So I can factor an r out of the first two, and I'm left with a plus b. Still have a plus here. And out of these next two, I can factor an s. A plus b. Now if you notice, I have r times this thing plus s times this thing. So now what I can do is I can take these two highlighted parts and factor it out front. Basically, I'm factoring out a common factor here. So I'd have an a plus b out front. And now a plus b times what gets me this whole thing? Well, just the r. Then we have plus a plus b times what gets me this whole thing? Times the s. So when I distribute this out, it's really interesting. Let's try distributing it out. I should get back to where I started. So if I distribute, let's multiply by the a. We have a times r plus a times s. Then multiply by the b, plus b times r plus b times s, b times s. So if you notice, I have AR, AS, BR, BS. So I have all the same terms. Okay. All right, let's look at example 3. A word of caution, be careful with the negatives. Okay. This -4, this is a -4. So a lot of times I come in and I rewrite them all as plus and negative when I'm grouping to make sure that I don't lose where my negatives belong, because it's a -4z and a -20. So now let's go ahead and let's see if we can factor this by grouping. So I'm going to group the first two. I'm going to group the last two, still a plus sign in between. Out of these two, I can take out a z to the second. I'm left with a z plus 5. Plus, let's see, out of these two, well, 4 goes into 20. I could take out a 4, and they're both negative, so I could take out a -4. So when I take a -4 out of this, I'm left with z. When I take a -4 out of that, I will be left with a plus 5. Now, do you notice this thing here and this thing here are the same? So now I can write that out front, z plus 5, and then now what's left? Z to the second plus a -4, which is -4. Okay. Now, am I done? Can I, or is this factored completely? Okay. To me, it looks like it's not, because I have z to the second -4 right there. That's a difference of squares. Always be looking for your difference of squares and sum and difference of cubes. So that will factor even farther. That will factor into z plus 2, z minus 2. Using difference of squares. Now I think I'm done. Okay. Alrighty. Okay. Okay. Our last form of factoring is factoring things that are quadratic in form. Okay, and we've already solved equations kind of like this where we use that u, let u equal. Okay, and so we're gonna do that here also. Basically, noticing things that are quadratic in form as you look to see, are these the square of anything? Because quadratic in form is a times u squared plus bu plus c. So I'm always looking to see, well, is this first thing the square of anything? Well, 16 is the square of 4. Now x to the 4th, well, if I square x to the second, I'll get x to the 4th, because we multiply those exponents. Okay. So this is quadratic in form. So this would be my quadratic. But I don't have a linear term. I don't have a bu in the middle. But I also do have a -81. That's the square of 9. So now this is actually a difference of squares. I have this thing squared minus this thing squared. So I can factor this using difference of squares. 4x squared plus 9. 4x squared minus 9. Okay. Ask myself, am I done? Well, this is a sum. Okay, and this one's a difference. Now I'm looking, is it a difference of squares or cubes? Well, I don't have any cubes, but this is a square. If I take 2x and square it, I get 4x squared. If I take 3 and square it, I get 9. So that's a difference of squares, so I can factor just this piece right here. So I need to factor that, so we'll have 4x squared plus 9, that's still this first term. And then this thing here is going to factor into 2x plus 3, 2x minus 3. Okay, I think we'll save this one for in class. Okay, that might be a good jumping off point. Okay, and now you're able to do the monitoring progress problems 4 through 9. Okay. All right, now what I'd like you to do is before you turn to the next page, I would like you to go ahead and divide 2x to the 4th plus 10x to the 3rd plus 11x minus x plus 6. I wanted you to divide that by x plus 3 and bring that to class ready to discuss. And in class, we will fill in the rest of your notes. So come prepared for class tomorrow. You need to come with any questions you had on the first or second page of these notes. You need to do the monitoring progress problems 1 through 3 and 4 through 9, and then you needed to divide this. You can use whichever method you'd like, synthetic or long division, whichever you prefer, and come to class ready to discuss. Good luck.